Hello everyone. In this video I am going to show you how to apply positive or rising edge and negative or falling edge in PLC programming in two different languages, ladder logic and SCL language. But first we need to know what is a positive edge or a negative edge. So let me explain in this diagram. Imagine we have got an input signal. The input signal can be your start button. For example, when you press the start button, it goes from low to high. And it stays high while you're holding the start button, and as soon as you release the start button, it goes low. Or the input signal can come from an output device, or like a motor, for example. Imagine, for example, when the motor turns on, it goes from low to high. So here you have a rising edge, which sometimes we call it positive edge. And at one point it goes low, or the motor turns off. So we have a falling edge. Sometimes we call it negative edge. So in general, we have got two different edges, positive edge and negative edge. I am going to show you two simple examples where we can apply these positive and negative edges. For example, if we need two motors to run simultaneously, we can apply the positive or the rising edge of the first motor to run the second motor. So if you want two motors to run simultaneously at the same time, as soon as the first motor starts working, you can use the positive edge of the first motor to run the second motor. However, if we need two motors to run continuously, that means when the first motor stops, the second motor starts working. In this case, we can apply the negative edge or the falling edge of the first motor to run the second motor. Always, when we apply positive or negative edges, so as soon as, for example, the first motor, if you apply the positive edge, as soon as the first motor runs, it sends a quick pulse to the second motor. But if you apply a negative edge, as soon as the motor number one turns off, at the same time, it sends a quick pulse to run the second motor. So let's go to the PLC programming. It will make more sense when we doing it in the programming. So before I start doing the programming, I already created my default tech table to make the job easier for us and save the time. So we have got two stop buttons for each motor, motor number one, motor number two. I am going to create another stop button for motor number three. Okay, so I have got three motors, motor number one, motor number two, motor number three, which I use the output addresses Q0.1, 2, and 3. And for the positive edge and negative edges in two different languages, I created 4 memory bits, as you see here. So 2 memory bits, positive edge and negative edge, memory bits numbers 0.0 and 0.1. I am going to use them in ladder logic. And the 2 other memory bits, 0.2, 0.3, which called the rising and falling edge, I'm going to use it in SCL language. And I have got 2 SR1 and SR2, 2 memory bits for my SR flip-flops in ladder logic. Okay, let's go to main OB1. So first we are going to do it in ladder logic. Of course, we need a start button to run the motor. That's going to be my start button. And also I need an output, which is my motor number 1. Okay. But as you know, normally in industry we have got momentary push buttons, so as soon as you press the start button, the motor turns on. However, when you release the start button, the motor turns off. So in this case, I need SR flip-flop to latch my input. So SR number 1, I have already created it in default tag table. Here I need a stop button to stop my motor number 1. I am going to use a stop number 1. Okay. So now, as soon as I press the start button, motor number 1 starts. However, I want the second motor to turn on. So I want the motor number 2 to turn on as soon as motor number 1 turns on. So in this case, I can apply a positive edge. Okay? So it's like normally open switch, but it has got 2 input address. It requires 2 input address. The top address is where the signal is coming from motor number 1. I said with the positive edge of motor number 1, motor number 2 should start. So the top address is motor number 1. The bottom address is always a memory bit address, which I am going to use a positive edge, which I have already defined it in default tag table, which is memory bit 0.0. However, as we know, positive edge is just a quick pulse, okay, for milliseconds. So I need something to keep my output high. Again, I will need another SR flip-flop in this case. So that's going to be my SR number 2. And then the reset to stop the motor number 2, I am going to use stop number 2. Here you go. So now the job is done. In ladder logic, we can basically download the program into the PLC. So if I monitor the program, so now I have a start button here. When I press it, motor number 1 turns on. However, motor number 2 is not connected directly to the start button. It's connected to the positive edge of motor number 1. So as soon as motor number 1 starts with the positive edge, motor number 2 will start at the same time. So let's test it. So I0.1 is my start button. As soon as I press the start button, motor number 1 starts, and with the positive edge of motor number 1, motor number 2 will start, as you see here. Okay, so now I'm going to stop motor number 1 and motor number 2. So now I am going to use the positive edge of motor number 2 to run the third motor simultaneously. Okay, I'm going to show you in SCL language. So now if I insert a network in SCL, I can show you how you can apply this basically positive and negative edges in SCL language. So in SCL language, bit logic operation looks a little bit different. In ladder logic, you had so many bit logic operations. Let's click on network number 2. In ladder logic, that's your bit logic operations. That's how many you have. However, in SCL language, you have got only two rising trig and falling trig. Everything else like SR flip-flops, you have to write the program in SCL language. So we have got only rising trig and falling trig in SCL language, which is the positive edge and the negative edge. So at the moment I am applying the positive edge. I press OK. Not much difference between ladder logic and SCL. Again, you have got two inputs required for your positive edge or rising trig. The top input where the signal is coming from, which I am going to say as soon as motor number 2 starts, I'm going to run motor number 3. So I type here motor number 2. Here you go. So that's where the signal is coming from. And the output in this case is the bottom address of the positive edge, which always needs to be a memory bit address. So in this case I am going to use rising edge, which I have already defined in default tag table. So now I've got my top address, motor number 2, and the bottom address, which is a rising edge, a memory bit. Now I am going to write the program for motor number 3. Okay, so as you know, I have created my positive edge in SCL language. You know, after the positive edge, we require SR flip-flop to keep the output high. However, in SCL language, we don't have a SR flip-flop prepared for us to apply and drag and drop. We need to write the program for it. So I have already explained it in the previous videos how to write a program for SR flip-flop in SCL language. We need to create an if function. We say if rising edge is equal to true, if the rising edge is equal to 1, and for the SR flip-flop, we know a stop button has got priority to a start button. So a stop button has to be false in this case. And when a stop button, I'm going to say the third stop button, which I'm going to use it for the motor number 3, is equal to low, then semicolon, then motor number 3 should be equal to true. So then motor number 3, as we are writing or changing the output status, we need to use colon equal to 1. Close the line with a semicolon, and then we need to apply an else function. So we say else if a stop button is true, is equal to true, then motor number 3 should be equal to false or off. As we already created two if function, so we need to and if. So program is completed. So we say when the rising edge that is coming from motor number 2 here is equal to high and a stop button is not activated at the same time, then the motor number 3 can turn on. Anything else, if a stop button is high, the motor number 3 has to be off. Okay, let's test this program. We go offline first. I am going to download this program to the PLC, load it, and finish. Okay, we can monitor the program now. Okay, let's have a look here. Okay, so we know if I press the start button, motor number 1 in the first network will run, and as soon as motor number 1 turns on with the rising edge, motor number 2 will run, and in the third network, which is in SCL language, as soon as motor number 2 starts running with the rising edge of motor number 2, motor number 3 will run. So let's test it. Okay, so now if I press the start button, which is the input I0.1. Okay, so as soon as I press the start button, you can see motor number 1 starts in the first network, and as you see, the positive edge is activated because motor number 1 has already activated. It sends a quick pulse, runs the motor number 2, and then the motor number 2 with the positive edge, it will send a quick pulse to run motor number 3. So now if I show you, you can see motor number 1, motor number 2 and motor number 3, all 3 are on. Okay, so now I am going to show you how to write the program for in ladder logic and SCL language for negative edges. Okay, so in this case, it's very simple. What I'm going to say, I'm going to say when I press the start button, motor number 1 starts working. As soon as I stop motor number 1, I want motor number 2 to start working. So they are going to work continuously, one after another, motor number 2 after another, after motor number 1. So in this case, I need to change that to a negative edge. Okay, and I'm going to change this address to negative edge. Okay, so now let's test it in ladder logic first. I am going to download this program, overwriting the main OB1, run the program. Okay, I'm going to stop motor number 1. So they are running from the previous program because I didn't stop them in the previous program. So I'm going to stop them now and basically run them again. Okay, so now you can see my motor number 1 is turned off. I am going to turn on my motor number 1 by a start button. So I press the start button, motor number 1 starts, as soon as the motor number 1 starts working, the negative edge became activated, but it's waiting for motor number 1 to stop, then it sends a quick pulse to the second SR flip-flop to run the second motor. So now, as soon as I stop motor number 1, you can see motor number 2 starts working. So that's how you can run 2 different outputs continuously. Okay, now we want to learn how to write this program in basically SCL language, which is very simple. Instead of a rising edge, I just need to use a falling edge. So now if I go to the instruction, bit logic operation, sorry, I need to click on the SCL network first, then open the bit logic operation. So in this case, we need a falling trig, and so the signal is coming from motor number 2, the falling edge. So I am going to call it motor number 2. And the output is going to be the falling edge. Okay, so now the SR flip-flop is going to be staying the same. However, instead of rising edge, this time I am going to have the falling edge. So now we can basically download the program into the PLC. So we say when the falling edge is so basically we are saying when the falling edge is equal to high and a stop button is not pressed, then motor number 3 should start. So if I go to the default tag table, I am going to see the stop 3 is I0.3. Okay. So now if I go back to the OB1 and monitor the program, it seems that the program is not been downloaded yet, so I go offline. Load the program and then finish. And now I can monitor the program. Okay. So you can see none of the motors at the moment is on. I am going to show you in the video as well. So as soon as I press I0.1, you can see motor number 1 turns on and the negative edge is waiting for the motor number 1 to stop, then motor number 2 can run. So by pressing I0.0, as soon as I press the stop button, stop motor number 1, motor number 2 will running. Here you go. So now motor number 2 is running. So now, as soon as I stop the motor number 2, motor number 3 will run. Okay. So now I0.2 is the stop button. So now as soon as I press the stop button, motor number 2 stops, and the next motor, which is number 3, will start working as you see here. Okay. Thanks for watching this video. I hope it makes sense to you.